to Number Crunch. Today we are tackling KCSE 2018 Paper 1 Section 2, and it starts with question 17. A school water tank is in the shape of a frustrum of a cone. The height of the tank is 7.2 meters and the top and bottom radii are 6 meters and 12 meters respectively. Part A. Calculate the area of the curved surface of the tank, correct 2 decimal places. We need to find the area of the curved surface of the tank. Assuming that is our tank, the first step, we need to find the height of the small cone. And since the small cone is similar to the big cone that forms part of the frustrum, it means that their heights are also similar, so we can equate the heights. And that means the total height of the cone, which is x plus 7.2 meters, over x, which is the height of the small cone, is equals to the radius of the big cone divided by the radius of the small cone. We cross multiply. We have 6 into x plus 7.2 is equals to 12x. Open the bracket. We have 6x plus 43.2 is equals to 12x. We subtract 6x from both sides of the equation. We have 43.2 is equals to 6x, which is similar to 6x is equals to 43.2. We divide both sides by 6 to find the value of x, which is 7.2 meters. Once we've found the height of the small cone, we shall use it to find the slanting height of the small cone and the slanting height of the large cone. And since the height, the radius, and the slanting edge form right-angled triangles, we shall use Pythagoras theorem to find those heights of the slanting edge. And so, the slanting height of the large cone will be the total height of the cone squared plus radius squared, then we find the square root. So, it's equals to the root of 351.36, which is equals to 18.74 meters. So, the slant height of the large cone is 18.74 meters. And the slant height of the small cone is the height of the small cone, which is 7.2 meters of the x, plus the radius of the small cone, which is 6 squared, then the square root, which is the root of 87.84, which is equals to 9.37 meters. So we have the length of the slanting height, and so the next step is to find the area of the curved surface. And we know that the area of the curved surface of a cone is equals to pi r L. But in our case, the tank is a frustrum. So we shall find the curved area of the total big cone minus the curved area of the small cone in order to find the area of the curved surface area of the frustrum. So we have our area is equals to pi r L of the large cone minus pi r L of the small cone. We substitute. I've used pi as 3.142 times 12, which is the radius of the big cone, times 18.74, the slanting height of the big cone, minus 3.142, the pi, times 6, that is the radius of the small cone, times 9.37, which is equals to 529.92972, but we have been asked to give our answer to 2 decimal places. Therefore, the area is 529.93 squared meters to 2 decimal places. Question 17, part B. Find the capacity of the tank in liters, correct to the nearest liter. We are supposed to find the capacity in liters. Capacity is similar to volume, so we are going to calculate the volume of the tank. And since we have a frustrum of a cone, we are going to find the volume of the big cone minus the volume of the small cone. And the area of the volume of a cone is a third pi r squared height. So for the large cone, it will be a third pi r squared h for the large cone minus a third pi r squared h for the small cone, h being the height from the tip to the bottom radius. So we have A third times 3.142 times the radius of a large cone is 12 meters squared times 14.4, which is a summation of 7.2 plus 7.2, minus a third times 3.142 times 6 squared, 6 being the radius of the top of the tank, times 7.2. We have 2171.7504 minus 271.4688, which is equals to 1900.2816 cubic meters. But we have been asked to give our answer in liters, and so we have to convert the cubic meters into liters. And 1 cubic meter is equals to 1,000 liters. So we need to find what 1900.2816 cubic meters is equals to. Because multiply, we obtain 1,900,281.6, but we have been asked to give our answer to the nearest liter. So it's approximately 1,900,282 liters. Question 17 part C. On a certain day, the tank was filled with water. If the school has 500 students and each student uses an average of 40 liters of water per day, determine the number of days the students will use the water. So we are going to start by finding the consumption per day, then find the number of days that the water could be consumed. So one student consumes 40 liters of water per day. We need to find how much the 500 students would consume. So we could cross multiply. We find that per day the consumption is 20,000 liters. If the consumption per day is 20,000 liters, what will 1,900,282 liters consumption be? So we cross multiply as well, and we obtain 95.0141, which is approximately 95 days. That means the water would have been consumed for 95 days if the tank was filled. Question 18. Two vertices of a triangle are A36 and B712. Find the equation of line AB. We've been given points A36 and point B712. The first step, we shall find the gradient of the line. And the formula of the gradient is change in y over change in x. So we are going to use the points A and B, where the change in y we have, starting with point B, 12 minus 6, then 7 minus 4, and that gives us 6 over 4, which is 3 over 2. Then we are going to use this in one of the points to find the equation. So 3 over 2 is equals to, we've used point A, is equals to y minus 6 over x minus 3. We cross multiply. We have 3 into x minus 3 is equals to 2 into y minus 6. Open the brackets, we have 3x minus 9 is equals to 2y minus 12. We add 9 to both sides. We have 3x is equals to 2y minus 3. Then we subtract 2y on both sides of the equation. We have 3x minus 2y is equals to negative 3. Since we've not been asked to express the equation in any format, we can leave it as it is. Question 18 part B. Find the equation of the perpendicular bisector of line AB. We need the perpendicular bisector, and so that means it's the midpoint of AB. One of the points it touches AB, it's at the midpoint of AB. And so, in reference to point A, we are going to take the x's of AB, subtract them, divide by 2, then add to point X, and Y, do the same, subtract the values of the Y values of A and B, divide by 2, then add the A value in order to obtain the midpoint. And so to do that, we have 7 minus 3, which is the Y values of A and B, divide by 2, then plus 3. Alternatively, you can do the values of b, which would have been 7 minus 7 minus 3 over 2, and for the y value we have 12 minus 6 over 2 plus 6, or 12 minus 6 over 2. So in our case we have used the values of a, and that gives us 5, 9. So the midpoint of AB is 5, 9, or one of the points of the perpendicular bisector. Then for a perpendicular bisector, the product of their gradients is equal to -1. And so the gradient of AB times the gradient of the perpendicular bisector is equal to -1. And in part A, we had computed the gradient of AB, which was 3 over 2. So 3 over 2 times the gradient of the perpendicular bisector is equal to -1. We multiply both sides by 2 over 3 in order to remain with the gradient of the perpendicular bisector, which is equal to -2 over 3. And since we have the gradient and one of the points, we can obtain the equation of the perpendicular bisector using the formula of gradient is equal to change in y over change in x. So -2 over 3 is equal to y minus 9, which is the y value of one of the points of the bisector, over x minus 5. We cross multiply, we have -2 into x minus 5 is equal to 3 into y minus 9. Open the brackets, we have -2x plus 10 is equal to 3y minus 27. We subtract both sides. We subtract 10 from both sides. We have -2x is equal to 3y minus 37. Then we subtract 3y from both sides. We have -2x minus 3y is equal to -37. That is the equation of a perpendicular bisector, and since we have not been asked to express it in any form, we can leave it as it is. Question 18 part C. Given that AC is perpendicular to AB and the equation of line BC is y is equal to -5x plus 47, find the coordinates of C. So we've been told that AC is perpendicular to AB, and if you can remember in part B, we were tackling a perpendicular bisector. So that means AC is parallel to the perpendicular bisector, and for perpendicular lines, their gradients are equal. Therefore, the gradient of line AC is equal to the gradient of the perpendicular bisector, which is equal to -2 over 3. Then, since we are dealing with line AC, it means one of the points where the line passes through is point A, and the coordinates of A was 3, 6. So we are going to use point A and the gradient of AC to find the equation of AC. So we have -2 over 3 is equal to y minus 6 over x minus 3. We cross multiply, we have -2 into x minus 3 is equal to 3 into y minus 6. Open the brackets, we have -2x plus 6 is equal to 3y minus 18. We add 6, we subtract 6 on both sides of the equation. We have 2x is equal to 3y minus 24. Then we subtract 3y on both sides of the equation. We have -2x minus 3y is equal to -24. So that is the equation of AC. Then we know that it's a triangle. So the line AC and BC meet at point C. And that means the values of x and y in both equations are equal at point C. Meaning, if we equate line AC, whose equation is, as we have computed, -2x minus 3y is equal to -24, and the equation of BC that we have been given, y is equal to -5x plus 47, the two equations form simultaneous equations. So we are going to solve them as simultaneous equations to find the values of x and y. So we have -2x minus 3y is equal to -24. and y is equals to negative 5x plus 47. So we shall substitute y with negative 5x plus 47. We open the bracket to have negative 2x plus 15x minus 141 is equals to negative 24. Put the like terms together, we have 13x minus 141 is equals to negative 24. We add 141 on both sides of the equations. We have 13x is equals to 117. We divide both sides by 13 and the value of x is equals to 9. Then we go back to our equation y to find the value of y, and y is equals to negative 5x plus 47. So we substitute with the value of x, which is 9. We have negative 45 plus 47, which is equals to 2. And so the coordinates of point C, which is the same as xy, is equals to 9 and 2. Question 19. The distance covered by a moving particle through point O is given by the equation s is equals to t cubed minus 15t squared plus 63t minus 10. Find part A, distance covered when t is equals to 2. So when t is equals to 2, we should find the distance covered. That means the distance covered from t equals 0 up to t equals 2. So to find that distance, you find the s of t equals 2 minus the s of t equals 0. Or alternatively, you can find s of t equals 0 plus s of t equals 1 plus s of t equals 2. So s of t equals 2 will be 2 cubed minus 15 into 2 squared plus 63 into 2 minus 10, which is equals to 64. And the s of t equals 0 will be 0 cubed minus 15 into 0 squared plus 63 into 0 minus 10, which is equals to negative 10. Therefore, the distance covered when t equals 2 is equals to 64 minus negative 10, which is equals to 74 units. Question 19, part B. Find the distance covered during the third second. The distance covered during the third second is s of t is equals to 3. So we have, that's the distance equation. So we substitute t with 3. We have 3 cubed minus 15 into 3 plus 63 into 3 minus 10, which is equals to 53 units. So the distance covered during the third second is 53 units. Question 19, part C. Find the time when the particle is momentarily at rest. So rest is related to velocity. So the first step, we need to find the velocity function, which is a differentiation of the distance function. So if our distance function is s is equals to t cubed minus 15t squared plus 63t minus 10, our velocity function will be 3t squared minus 30t plus 63. If you need further help in doing differentiation, just leave a comment below. Then at rest, the velocity is equals to 0. So that means our velocity function is equals to 0. And so we need to find the factors of negative 30 whose product equals 3 times 63. And the factors are negative 9 and negative 21. Then the common factors between 3t squared and negative 9 is 3t. So 3t into t minus 3 minus 21 into t minus 3 is equals to 0. 3t minus 21 into t minus 21 is equals to 0. So that means 3t minus 21 is equals to 0, or t minus 3 is equals to 0. We add 21 to the first equation on both sides. We have 3t is equals to 21, and we add 3 to the second equation, so t is equals to 3, or t is equals to 7. So that means the particle is at rest at t is equals to 3 seconds or t is equals to 7 seconds. Question 19 part D. Find the acceleration when t is equals to 5. So acceleration is the differentiation of the velocity function. So we need to differentiate the velocity function, and our velocity function is 3t squared minus 30t plus 63. Therefore, our acceleration function will be 6t minus 30. Then we need to find the acceleration when t is equal to 5. So we substitute t with 5. It becomes 6 into 5 minus 30, which is 30 minus 30, hence 0. So acceleration at time t equals 5 was 0. Question 20. The diagram below shows triangle ABC with vertices A -1, -3, B 1, -1, and C 0, 0, and line M. Part A. Draw triangle A prime, B prime, C prime, the image of triangle ABC under a reflection in the line M. The first step is to identify the reflection points of the triangle. So for point A, since we have -1, -3, its reflection, which will be from point A to line M, will be the same as, will come to this point, will be -4, 0. The reflection of point B, which is 1, -1, will be -2, 2. And the reflection of point C, which is 0, 0, will be -1, -1. So this will be our A prime, our B prime, and C prime. Then you join the dots. And there we have our reflection of triangle ABC. Remember that a reflection is it's the same as a mirror image of an object. Question 20 part B. Triangle A2 prime, B2 prime, C2 prime is the image of triangle A prime, B prime, C prime under a transformation represented by the matrix T is equals to 1, 0, 2, 1. Part 1. Draw triangle A2 prime, B2 prime, C2 prime. So the first step before you draw, you need to remember the coordinates of A prime, B prime, C prime, which we have done in part A. And the coordinates are -4, 0, -2, 2, and -1, 1. Then we've been given a transformation matrix. So we are going to multiply the transformation matrix by the vertices of the triangle to find the coordinates of the new points. So we have 1, 0, 2, 1 times -4, 0, -2, 2, and -1, 1. So if you have a problem multiplying matrices, just leave a comment below and we shall expound on that. So that results to -4, 0, 2, 2, and 1, 1. So the new points of A2 prime is -4, 0, B2 prime is 2, 2, and C2 prime is 1, 1. So we go ahead and draw the new image. The coordinates of A2 prime is negative 4, 0, which is the same as A prime. B2 prime is 2, 2. So we have it at that point. And C2 prime is 1, 1. So that will still be our A2 prime, our B2 prime, and C2 prime. Then you join the points. And that's the triangle A2 prime, B2 prime, and C2 prime. Question 20, part B2. Describe fully the transformation represented by matrix T. And matrix T is 1, 0, 2, 1. Then general rules for matrices. The general matrix for a shear parallel to the x-axis is 1, 0, A1. Therefore, the transformation of A prime, A2 prime, B2 prime, C2 prime, represented by the transformation of matrix T, is a shear of factor 2 parallel to the x-axis. Question 20, part 3. Find the area of triangle A prime, B prime, C prime. Hence, find area of triangle A2 prime, B2 prime, C2 prime. So there is a formula to find the area of a triangle given the coordinates of the points. And remember, the coordinates of the points A prime, B prime, C prime were what we computed in part A. So the formula of the area of triangle A prime, B prime, C prime is the absolute value of a half into the x value of A prime into the y value of B prime minus the y value of C prime plus the x value of B prime times the y value of C prime minus the y value of A prime plus the x value of C prime times the y value of A prime minus the y value of B prime. Then we substitute the figures. We have the absolute value of a half into negative 4 into 2 minus 1 plus negative 2 into 1 minus 0 plus negative 1 into 0 minus 2. We simplify this. We have the absolute value of a half into negative 4 minus 2 plus 2. This is the same as the absolute value of a half times negative 4, which is the absolute value of negative 2, hence giving us 2. So the area of A prime, B prime, C prime is 2 squared units. Then remember that to obtain A2 prime, B2 prime, and C2 prime, we had to use the transformation matrix 1, 0, 2, 1. So we need to find the determinant of the transformation matrix T, and the determinant is 1 times 1 minus 2 times 0, which is equals to 1. Then now the area of A2 prime, B2 prime, C2 prime is equals to the area of A prime, B prime, C prime times the determinant of the matrix T. We substitute, we have 2 times 1, which is equals to 2 squared units. Therefore, the area of A2 prime, B2 prime, C2 prime is equals to 2 squared units. Question 21. The figure below shows two triangles ABC and BCD with a common base. BC is equals to 3.4 centimeters, AC is equals to 7.2 centimeters, CD is equals to 7.5 centimeters. and angle ABC is equals to 90 degrees. The area of triangle ABC is equals to area of triangle BCD. Calculate correct one decimal place. Part A, the area of triangle ABC. We've been told that triangle ABC is a right angle triangle, and so to find the area we can use the formula a half base times height. However, we've been given the base, but we've not been given the height, so we first have to compute the height of triangle ABC. And to do that, we use Pythagoras theorem, which states a squared plus b squared is equals to c squared, where a and b is the base and the height, and c is the hypotenuse. So that means ab squared plus bc squared is equals to ac squared. We substitute the figures. We have ab squared, which is the height, plus 3.4 squared is equals to 7.2 squared. ab squared plus 11.56 is equals to 51.84. We subtract 11.56 from both sides of the equation. We have ab squared is equals to 40.28. We square root both sides to remain with AB, and AB is 6.3 centimeters to one decimal place. Now we have the height and we have the base, so we calculate the area. And as we stated earlier, area is a half base times height. We substitute, we have a half times 3.4 times 6.3, which is equals to 10.71, but we have been asked to give our answer to one decimal place. Therefore, area is 10.7 square centimeters to one decimal place. Question 21, part B. Calculate one decimal place the size of angle BCD. We've been given the length of BC as 3.4 centimeters, CD as 7.5 centimeters, and we have obtained the area of ABC, which is equals to the area of BCD, and it's equals to 10.7 as obtained in part A. So since we've been asked to find the angle BCD, we can use the formula of obtaining the area of a triangle given two sides and the angle between them, and the formula is a half AB sine C, whereby our A is BC, our B is CD, and sine C is sine angle BCD, which we can leave it as sine C. We substitute the figures. We have 10.7 is equals to a half times 3.4 times 7.5 sine C. 10.7 is equals to 12.75 sine C. We divide both sides by 12.75 to remain with sine C, and that gives us 0.8392. And so to obtain C, we need to find the inverse sine of 0.8392. And if you use your calculator, you will obtain the value 57.0574. But remember, angle BCD is an obtuse angle. Therefore, we have to subtract the value we have obtained from 180 degrees. And so our angle C is 122.9426, but we have been asked to give our answer to one decimal place. Therefore, it will be 122.9 degrees. Question 21, part C. Calculate correct one decimal place the length of BD. Since in part B we found the angle BCD, to find length BD, we shall use the cosine rule, and the cosine rule states C squared is equals to A squared plus B squared minus 2AB cos C. In relation to our triangle BCD, C is BD, A is BC, B is CD, and cos C is cos BCD. And so our BD squared is equals to BC squared plus CD squared minus 2BC times CD cos C. We substitute the figures. We have 3.4 squared plus 7.5 squared minus 2 times 3.4 times 7.5 cos 122.9 degrees. This equals to 11.56 plus 56.4 -0.25 minus -47.40, which is equals to 115.21. To get BD, we square root both sides, and so BD is 10.73, but giving our answer to 1 decimal place, BD is equals to 10.7 centimeters. Question 21, part D. Calculate correct 1 decimal place the size of angle BDC. Since we have obtained length BD and angle BCD, and we know length BC, we can use the sine rule to find the size of angle BDC. And the sine rule is A over sine B, that is the side of a triangle over the sine of the opposite angle, is equals to B over sine B, which is equals to C over sine C. So in relation to triangle BDC, we have BD is equals to, BD over sine C is equals to BC over sine D. BD is 10.7, C is 122.9 degrees, and BC is 3.4 centimeters. Therefore, 10.7 over sine 122.9 is equals to 3.4 over sine D. We cross multiply, we have 10.7 sine D is equals to 3.4 sine 122.9. We divide both sides by 10.7, and so sine D is equals to 3.4 over sine 122.9 over 10.7. Sine D is equals to 0.2668. So angle D is the inverse sine of 0.2668, which is equals to 15.47, and to 1 decimal place it's 15.5 degrees. Question 22, part A. On the grid provided, draw the graph of y is equals to 4 minus a quarter x squared for x is greater or equals to -4 and x is less than or equals to 4. We have been asked to plot a graph of y is equals to 4 minus a quarter x squared for the ranges of x is between -4 and 4. So the first step, we are going to find the values of y for the given values of x. We have our x and y. We have -4, -3, -2, -1, 0, 1, 2, 3, and 4. So if you compute the values of y for the given values of x, you obtain where x is -4, y is 0. Where x is -3, y is 1.75. Where x is -2, y is 3. Where x is -1, y is 3.75. Where x is 0, y is 4. Where x is 1, y is 3.75. Where x is 2, y is 3. Where x is 3, y is 1.75. And where x is 4, y is 0. Then now we plot the points. This is 0, 1, 2, 3, and 4. And this is our x-axis. -1, -2, -3. and negative 4. Then we have 1, 2, 3, and 4. And this is our y-axis. So where x is negative 4, y is 0. So we have 0.40. We have point negative 3, 1.75. This is 1.5. 1.75 will be at this point. Negative 2, 3. Negative 1, 3.75. 3.5, so 3.75. 0, 4. 1, 3.75. 2, 3. 3, 1.75. and 4, 0. Then we are supposed to join the dots to form the curve y is equals to 4 minus a quarter x squared. Wrongly here. There we have our curve y is equals to 4 minus a quarter x squared. Question 22, part B. Using trapezium rule with 8 strips, estimate the area bounded by the curve and the x-axis. So we need to estimate the area using the trapezium rule with 8 strips. So this being the graph we have drawn in part A, we need to subdivide the area under the curve into 8 strips, and it can be subdivided at the x values. So we shall have at that point, and at x is equals to negative 3 forms the first strip. We have the second one, the third, fourth, fifth, sixth, seventh, and the eighth one. And since we have obtained the eight strips under the curve, we can see that they are of uniform height of unit 1, since the difference between negative 4 and negative 3 is 1, negative 3, negative 2 is 1. All across we have a uniform length of 1. Then for the length of the trapeziums, they correspond to the y values that we had calculated in part A. So for example, the first y value is 0, the second one is 1.75, the third is 3, the fourth is 4, and so on. Then since we know that to obtain the area of a trapezium, the formula is a half h into a plus b, h being the height and a plus b being the varying length. So we can substitute that with the figures. We have a half times 1, which is the uniform length, into 0 plus 1.75, which are the first and the second values of y as we had calculated. Then we have a half times 1 into 1.75 plus 3, plus a half times 1 into 3 plus 3.75, plus a half times 1 into 3.75 plus 4, plus a half times 1 into 4 plus 3.75, plus a half times 1 into 3.75 plus 3, plus a half times 1 into 3 plus 1.75, plus a half times 1 into 1.75 plus 0. This simplified will be 0.875 plus 2.375 plus 3.375 plus 3.875 plus 3.875 plus 3.375 plus 2.375 plus 0.875, and when you sum all these up, you obtain 21 squared units. So that is the area under the curve using the trapezium rule and used with 8 strips. Question 22, part C. Find the area estimated in part B above by integration. So we are supposed to use integration to find the area under the curve that we drew in part A, and through integration the area will be the integration of 4 minus a quarter x squared between 4 and negative 4, which is the range of the curve. This becomes 4x minus x raised to power 3 divided by 12 between 4 and negative 4. We substitute the figures we have into 4 times 4 minus 4 cubed divided by 12, the whole of it minus 4 times negative 4 minus negative 4 cubed divided by 12. We simplify this, we have 10 raised to power 2 over 3 minus negative 10 raised to power negative 2 over 3. So this is the same as 10 raised to power 2 over 3 plus 10 raised to power 2 over 3, which is equals to 21 and a third squared units. So using integration, the area is 21 and a third squared units, but using the trapezium rule, we obtain the area as 21 squared units. Question 22, part D. Calculate the percentage error in estimating the area using trapezium rule. So we need to find the percentage error, and the formula of calculating the percentage error is equals to the actual value minus the estimate divided by the actual times 100. In our case, the actual is the value obtained using the integration method, and the estimate is the value obtained using the trapezium rule. So we substitute the figures. We have 21 and a third minus 21 divided by 21 and a third times 100, which is equals to a third divided by 64 over 3. We have rearranged the 21 and a third into an improper fraction times 100. Simplify this, we have a third times 3 over 64 times 100. The 3 and 3 cancel, so we have 1 over 64 times 100, which is the same as 100 over 64, and this gives us 1.5625%. Therefore, the percentage error is 1.5625%. Question 23. 3 business partners, Abila, Bwire and Chirchir, contributed 120,000, 180,000 and 240,000 Kenya shillings respectively to boost their business. They agreed to put 20% of the profit accrued back into the business and to use 35% of the profits for running the business official operations. The remainder was to be shared among the business partners in the ratio of their contribution. At the end of the year, a gross profit of 225,000 Kenya shillings was realized. Part A, calculate the amount, section 1, put back into the business. So we need to find the amount put back in the business, and that amount was 20% of the profit. And so we have 20 over 100 times 225,000, which was the gross profit, and it's equals to 45,000 Kenya shillings. Question 23, part A, section 2. Calculate the amount used for official operations. The amount used for official operations was 35% of the profits. So we have 35% of 225,000, and it's equals to 78,750 Kenya shillings. Question 23, part B. Calculate the amount of profit each partner got. So to obtain the amount of profit each partner got, we first need to find the profit that was shared amongst themselves. And to do that, we have to subtract the 20% that was put back into the business and that 5% that was used for operations. And therefore, we have the profit shared is equals to gross profit minus amount put back plus amount for operations, which is 225,000 minus 45,000 plus 78,750, and that equals to 101,250 Kenya shillings. That was the amount that the three partners shared. Then the ratio of their sharing was 120,000, 180,000, and 240,000 respectively, which can be simplified to 2 to 3 to 4. And the total ratio is 2 plus 3 plus 4, which is equals to 9. Therefore, the contribution of Abila was 2/9 times 101,250, which is equals to 22,500. That was the amount that Abila got. Bwire got 3/9 times 101,250, which is equals to 33,750. And Chirchir got 4/9 times 101,250, which is equals to 45,000. So that was their respective shares that they got after putting back the profit and putting aside some money for operations. Question 23, part C. If the amount put back into the business was added to individuals' shares proportionately to their initial contribution, find the amount of Chirchir's new shares. So to obtain the amount of Chirchir's new shares, we are going to add the old shares plus the amount that was put back proportionately, and that is, we have the old share plus portion, which is the old share was 240,000, and the proportion, remember the ratios we have computed in part B, Chirchir's ratio was 4/9 times 45,000, which was the amount that was put back, as we had computed in part A, section 1, and that is equals to 240,000 plus 20,000, which is equals to 260,000. So the new share, Chirchir's new share, is 260,000. Question 24. The equation of a curve is given as y is equals to a third x cubed minus 4x plus 5. Determine, part A, the value of y when x is equals to 3. So to find the value of y when x is equals to 3, we substitute x by 3, and that becomes y is equals to a third into 3 cubed minus 4 into 3 plus 5, which simplified becomes 9 minus 12 plus 5, which is equals to 2. So the value of y when x is 3 is 2. Question 24, part B. Determine the gradient of the curve at x is equals to 3. So we need to find the gradient at x is equals to 3. The first step is to find the gradient equation. And to find the gradient equation, since the equation of the curve is a third x cubed minus 4x plus 5, we need to differentiate that equation to find the gradient equation. And to differentiate, you multiply the powers of the unknown terms times the coefficient, then you subtract the power by 1. So for example, the first part will be a third times 3, which is 1x raised to 3 minus 1, which is 2. So the gradient function will be the differentiation of dy over dx, which is equals to x squared minus 4. Then we've been asked to find the gradient at x is equals to 3. So we are going to replace x by 3, giving us 3 squared minus 4. And therefore the gradient at x is equals to 3 is equals to 5. Question 24, part C. The equation of a curve is given as y is equals to a third x cubed minus 4x plus 5. Determine the turning points of the curve and their nature. So to find the first part, to find the turning points, we need to use the gradient function. And remember, in part B we had obtained the gradient function as x squared minus 4 is equal to x squared minus 4. Then at turning point, the gradient of the curve is equals to 0. Therefore, we equate our gradient function to 0, and that gives us x squared minus 4 is equals to 0. Then we can rewrite this expression to be x squared minus 2 squared is equals to 0. And if you remember the quadratic identities, if you have a squared minus b squared, you can rewrite it as a minus b, a plus b. So we can rewrite our x squared minus 2 squared as x minus 2, x plus 2. So we have x minus 2 into x plus 2 is equals to 0. And so this means x minus 2 is equals to 0, or x plus 2 is equals to 0. We go ahead and find the value of x, where in the first part we add 2 on both sides, and the second part we subtract 2 on both sides. So x is either 2 or negative 2. Then remember the equation of the curve was y is equals to a third x minus 4x plus 5. So we substitute the values of x to find the values of y. So we have, when x is 2, our y will be a third into 2 cubed minus 4 into 2 plus 5. And when x is negative 2, our y is a third into negative 2 cubed minus 4 into negative 2 plus 5. This simplified becomes 2 over 3 minus 8 plus 5 and negative 2 over 3 plus 8 plus 5. Therefore, our values of y are negative 3 and 10 and a third. So to determine the nature of the turning points, we use the y values, where the smaller y value becomes the minimum turning point and the greater y value is the maximum turning point. And you write your turning points as coordinates of a point. So we have our turning points as 2, negative 1 over 3, which is the minimum turning point, and negative 2, 10, 1 over 3, which is the maximum turning point.